Good morning, friends and dear students. It gives me immense pleasure to be here again for my next lecture on flight mechanics. I am in the process of solving some numericals from different modules. That is called the problem solving. In the previous lecture, I have done with the landing performance, how much runway is required, how much length is required for the rolling, for translation, for airborne, total ground roll. These all things we have done some 3 to 4 numericals. Today we are going to discuss about problem solving and climb performance. And you know that what is the meaning of climb? Once I say the climb, so I will discuss about the climb first. So if I am first I will start the engine, then I will taxi, and then when I reach the end of the runway, I will wait for the clearance. From there, the takeoff procedure starts. Aircraft pilot will cue the throttle and aircraft will accelerate from 0 to the takeoff speed. We are taking the average speed, average method we are adopting for our relations. So as and when it is takeoff, and as we receive the proper airspeed which is required for the takeoff, pilot will use the elevator down, elevator up, so that nose will go up. As when nose will go up, it will start climbing. This is called the climb. So in this climb, this is called the climb angle, gamma. So this gamma is very important. So we will be discussing today few numericals on this problem. I am Dr. Yagya Dutta Dwivedi, professor from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. In my today's lecture, the overview is like that. Calculate the rate of climb, calculate time to climb, calculate maximum climb angle. So these are the few things which I will be discussing, some 3 to 4 numericals we will be solving in this today's lecture. So I will start from the first lecture, that is the first numerical, that is numerical number 1. A business jet aircraft with a mass of 12,700 kg and 2 turbofan engine, each generating a thrust of 23.7 kilonewton, is climbing with an airspeed of 250 knot. If the aircraft drag is 12,000 Newton, determine the rate of climb and the climb angle. So we have to find out the ROC, that is called the rate of climb, and the climb angle is gamma. In addition, how high the aircraft will fly, and also we have to find out in 2 minutes how much height your aircraft is going to cover. Ignore the variation of the aircraft weight, drag and engine thrust during this period. We are assuming that during this climb, the aircraft weight is constant, drag is also constant, and the engine thrust is also constant. These all parameters are constant. We have to find out the rate of climb. We know what is the meaning of rate of climb. If this is your gamma, your aircraft is here, it is going in this way. So this is the rate of climb. So we can write that ROC is equal to V sine of gamma. So this we have to find out. So to find out this, V is given. We have to find out the gamma. First we have to find out the climb angle. If we find the climb angle, then we can multiply it by the velocity. We will get the rate of climb. It is very simple and we will see here. So we will start with given parameter. Here mass M is equal to 12,700 kg this we can make 12,700 into 9.81 Newton. That is the first thing. The second thing is given thrust is equal to 23.7 into 1000 because it is kilonewton, so I have made the Newton. Velocity V is given 250 knot. I have to change in meter per second, so 250 into 0.5144 in meter per second. Time to climb, T is given as a 2 minute. I can write 2 into 60 or 120 second. So these are the things which given. So we have to find out first rate of climb. So I will start first a rate of climb, that is called ROC, and we know that this ROC is equal to T minus D into V by W. So here T is given, D is also given, yeah, drag is also given. I have not mentioned here. Drag is also given 12,000 Newton. So now I have to find out T. Two engines are there, so 2 into 23.7 into 1000, this one here, minus 12,000 divided by weight is 12,700 into 9.81 into velocity. Velocity is 500 into 0.5144. If you solve this, you will get rate of climb is equal to 36.55 meter per second. So one, we have got the answer, that is rate of climb. Now we have to find out the climb angle. So what is the climb angle? Climb angle gamma. So if I make like this, this is the gamma, your aircraft is here, this is the velocity. So this is your gamma and this is the ROC, rate of climb, and this is the range. And okay, so this gamma, we know that sine gamma is equal to rate of climb by V. Okay, rate of climb by V. So gamma is equal to sine inverse, rate of climb is 36.55 divided by V is equal to 250 to 0.5144. So you will get this gamma is equal to 0.288 radian. This is equal to gamma is equal to 16.5 degree. So this is the gamma and you got this 16.5 degree, it is climbing. So it is like this, your aircraft, and now it is this only small. This is the, like this it is taking off. Now okay, we will see that we have to find out the H, how much height. So this we can find out by, we know that rate of climb is equal to, this is the DH, and how much time? So DH by DT. So we have to find out H is equal to ROC by T. ROC we have got 36.55, 2 into 60. So you will get H is equal to 4386.7 meters or 14,392 feet. So this is the height, because we know that 1 meter is equal to 3.33 feet And we have to height of the aircraft we always give in the feet. So we have taken as a feet here. Also 1 knot is equal to 0.5144 meter per second. These two things we have to remember, because these things are used for our different conversion of the systems. So now we will go for the next numerical number 2. The aircraft A is climbing with a speed of 200 knot and climb angle of 15 degrees. So aircraft A, the speed of this thing is 200 knot and the climb angle is 15 degree. Another aircraft, that is the B, is climbing with a speed of 100 knot, lower velocity, and the climb angle is more. Determine which aircraft has the highest rate of climb. So we have to see rate of climb for each aircraft, that is the aircraft A and the aircraft B, and which one has got more rate of climb, that we have to find out. Next is determine the time to climb to 10,000 feet altitude of aircraft A and B, ignoring the variation of engine thrust with altitude. So it is very nice questions I will be discussing here. So this, I am dividing this thing into 2 parts here. So what is the given first? VA, velocity of the aircraft A is given 200 knots. We can write 200 into 0.5144 meter per second. Climb angle gamma A is equal to 15 degree. Speed of the B aircraft, this is the A aircraft. So here VB is given 100 knots, 100 into 0.5144, and gamma B is given 30 degree at H is equal to 10,000 feet. So now we have to find out A. For aircraft A, ROC of A, we know that V into sine of gamma, V is equal to 200 into 0.5144 into sine gamma is equal to 15 degree. So here we will get that 26.63 meter per second or 5243 feet per minute. Now for ROC of aircraft B, this is the aircraft A. So we can write is VB into sine of gamma B. VB is 100 into 0.5144 into sine 30 degree. We can write it 25.72 meter per second, 5063.4 foot per minute. So we got this rate of climb for this aircraft. Now we will find out the time of climb. So B, time of climb. So how to find this time of climb? We know that rate of climb is equal to h by t. So t is equal to h into rate of climb. So for A aircraft, TA is equal to HA into ROCA. HA is equal to T is equal to, so TA is equal to H by ROCA. H is equal to 10,000 feet and the rate of climb is 5242 for A. So we will get this value as 1.908 minute. Now for B aircraft, TB is equal to 10,000 divided by ROCB. 10,000 feet divided by ROCB is 5063.4, 1.975 minute. So it takes, aircraft B takes more time. So aircraft B takes more time to climb. Okay, so this is the problem which we have understood. Now we will go for the problem number 3. So here is the problem. Aircraft A is climbing with a speed of 180 knot and the ROC is 2600 feet per minute. Aircraft B is climbing with a speed of 150 knot and ROC of 3000 feet per minute. Which aircraft has the highest climb angle? So this we have to see here. What are the things are given. So here also I will just divide into the 2 part. Given for aircraft A. Velocity of aircraft A, VA, is equal to 180 knot. Rate of climb of A is equal to 2600 feet per minute. Same way for the B aircraft, VB is equal to 150 knot and ROC B is equal to 3000 feet per minute. So we have to find out what is the climb angle. This is called the climb angle. We have to find out. So now we will go with the solution. So we know that the rate of climb of any aircraft A is equal to the velocity of that aircraft VA into sine of gamma A. So we have to find out gamma A is equal to sine inverse ROC of VA. So it is a sine inverse. Rate of climb for A aircraft is 2600 divided by VA. VA is 180 into meter per second, 4144 into 196.85 to convert in feet, because above this one is feet per minute, so we have to make in the feet per minute. So we got here gamma A is equal to 8.2 degree. So this is the climb angle of the aircraft A. Now we know that ROC of B is equal to VB into sine gamma B. So gamma B is equal to sine inverse ROC of B aircraft divided by VB. If we put this value, so here 3000 divided by 150 into 0.5144 into 196.85. So this gamma B is equal to, you will get 11.4 degree. So we got this gamma A and the gamma B. So the climb angle, if you see here, the climb angle of aircraft B is higher than the climb angle of A. So, if your speed is high, then mostly the climb angle will be high. So, this is the conclusion for this problem. Now, we will see the next problem, which is the problem number 4. Okay, so this we'll see here. I will just read out this problem. Consider the business jet aircraft Hawker 800 with a mass of 12,700 kg and a maximum engine thrust of 2 into 23.7 kilonewton, because we have the two engines. So it is mentioned here 2 into 23.7 kilonewton. Assume the pilot is utilizing the maximum thrust in a climbing flight, and the following characteristics: S is equal to 34.75 meter square, CD naught is equal to 0.02. Okay, it is not this thing, it is 0.02. K is equal to 0.05. Plot the variation of rate of climb and climb angle with respect to the altitude. Include the variations of the engine thrust during this period. Ignore the reduction of the aircraft weight and its climb. So these are the few things which we have to solve. So here the solution is given here, that as the aircraft climbs, the engine thrust declines with altitude. Furthermore, the aircraft velocity is not constant, and so the drag is varied too. Two climb governing equations are as follows: sin gamma is equal to T minus D by W and cos gamma is equal to L by W. So if you see here, the variation of H for the different parameters are okay here given. We can find out the gamma. Okay, we'll see here. I will just, okay, so we see the problem here. What are the things given here? Just we'll see it. So we'll go to the problem number 5. The fighter aircraft McDonnell F4C Phantom has two turbojet engine, each generating 75.6 kilonewton of thrust. Other characteristics of the fighter aircrafts are: M is equal to 24,765 kg, S is equal to 49.25 meter square, CD naught is equal to 0.029, span is equal to 11.7 meter, E is equal to 0.6, CL max is equal to 2.2. Assume CD naught is a constant at all altitude. Analyze the steepest climb for this aircraft. So we have to find out the steepest climb. Determine maximum climb angle at sea level and at 30,000 feet altitude. Then calculate the corresponding ROC at both altitude. So at the sea level and at the 30,000 feet. We have to see in two conditions. So we will see here that given thrust T is equal to 7.56 kilonewton, 75,600 Newton, okay, into 2, because here we have the 2 this thing. Mass M is equal to 24765 kg into 9.81 Newton. Area S is equal to 49.24 meter square. CD naught is equal to 0.029. Span B is equal to 11.7 meter. E is equal to 0.7. CL max is equal to 2.2. So at sea level, first we have to see at sea level, we have to find the result. So okay, at sea level. So we know that aspect ratio is equal to B square by S. 11.7 square by S is equal to 49.24. You will get 2.78. K is equal to 1 by pi aspect ratio E. 1 by 3.14 into aspect ratio 2.78 into 0.7. You will get this K is equal to, you will get 0.164. CD max is equal to 2 CD naught. 2 into CD naught 0.029, 0.058. This you got the CD maximum. So now we have to find out V velocity when gamma is maximum. This is equal to 2W by rho S to power 1 by 2 into K by CD naught power 1 by 4. So 2 into W is equal to 24765 into 9.81 divided by 1.225 into S is equal to 49.24 power 1 by 2, and K we have got here 0.164 divided by CD naught 0.058 power 1 by 4. So we will get this as a 138.49 meter per second. So we got V gamma maximum this much. So if we have to compare, with stall speed Vs, and Vs is equal to under root 2W by rho S CL max. You will get here 2 into 24765 9.81, 1.225 into 49.24 into 2.2. You will get 60.5 meter per second. So here it is 138.49. So V gamma max is greater than Vs, so acceptable. Your design is acceptable because your this thing is okay. So now the minimum drag we have to find out. Minimum drag, and this drag that is called D minimum is equal to half rho V square S CD minimum, half rho V square, and here it is a minimum drag. So here you will get D minimum is equal to 1 by 2, 1.225, velocity is 49.24 into 0.058 into 138.49 square. You will get this value as 33549.7 Newton. This is the drag, minimum drag. So maximum climb angle gamma max is equal to sine inverse T max minus D minimum divided by W minimum. So sine inverse T max we got 2 into 75.6 into 1000 minus D minimum we got 33549.7 divided by weight 24765 into 9.81. So we got this 28.96 degree. This is the maximum climb angle for this aircraft. So we can now find out the ROC, rate of climb. So this I will put here some other color. ROC gamma max is equal to V gamma max into sine gamma max. So here we can write it that V gamma max we got 13, V gamma max we have got 138.49 into sine inverse 28.96, and we got this value as 67.05 meter per second. So this is your gamma. So this we have already done. Now we will see for the case B at sea level at 30,000 feet. So here density is equal to 0.4586 kg per meter cube, and we have to find out V gamma max is equal to 2 mg by rho s power 1 by 2 into 0.164 divided by 0.029 to power 1 by 4. We will get this as here 2 to 6.34 meter per second. Now if we compare with Vs, so Vs we will get here 2 mg divided by rho s CL max 2 into m is equal to 24765 9.81 divided by rho is equal to 0.4586 into 49.24 into 2.2, and here you will get 98.96 meter per second. Okay, so here we got it, and it is the maximum climb angle speed is higher than the stall angle, so it is acceptable. So now we have to find out the D minimum. I will just change the color. D minimum half rho s CD minimum into V minimum drag square. So half into 0.4586 49.24 into 0.058 into 138.49 square. You will get this D minimum as 24038 Newton. So from here we can get the, now at 30,000 feet, the engine thrust is reduced. Engine thrust is decreased as T is equal to T by T naught is equal to rho by rho naught to the power 0.9. So T is equal to T naught rho by rho naught 0.9. So we can get it like that, that 2 into 75.6 into 1000 into rho by rho 1. 0.4586 divided by 1.225 to power 0.9, and you will get this as a 62448.2 Newton. So this is the thrust. This much thrust you will get. So gamma max, we can find out that sine inverse T max minus D minimum divided by W minimum. So here sine inverse 62448.2 minus D minimum, we got 24038.3 divided by 24765 into 9.81. So we will get this as a 6.83 degree. Gamma max is equal to 6.83 degree, and we can also find out the rate of climb. So ROC max is equal to V gamma max into sine gamma max. So we can see here that V gamma max is equal to 226.34 into sine 6.83. So we will get here this 5297.3. We will get here, first we will write in meter per second, 26.92 meter per second, or we can write 5297.3 feet per minute. So this is the answer. So we can say that the climb at high altitude is significantly reduced. So if you are flying at high altitude, your rate of climb will be significantly reduced. If we see the earlier one, in this rate of climb was 67.0 meters, but here we are getting 26.92 meter per second. Very tremendously decrease in the rate of climb is observed. So in the next lecture, I am going to discuss about calculation of the thrust and the lift, calculate the increase in thrust, calculate maximum lift by drag ratio, calculate range and different flight conditions. These are the references: Anderson J.D. Jr., Aircraft Performance and Design, International Edition, McGraw-Hill's first edition, 1999. SL by M.E., Aircraft Performance Theory and Practice, AIA Education Series, AIA 2. Any questions, you are welcome to ask. My email ID is yddwivedi@gmail.com. Please do like and subscribe my channel. Hope you will enjoy. I am doing a lot of numericals. Please do practice with these problems. Thank you very much for the joining. Please be tuned for my next lecture.
Like, share and subscribe. Hit the bell icon for more updates.